HY-TEK Bio's product is a technology that allows you to burn fossil fuels, coal, oil, natural gas, even methane, and have no greenhouse gas emissions, zero emissions. Okay, so how do we do that? What are the components of doing that? One is we have algae that will consume the CO2 and the nitrogen oxides in the flue gas, the greenhouse gases. And any algae will do that. But our algae, which we've isolated with the University of Maryland, Dr. Feng Chan's office at the University of Maryland Center for Environmental Sciences, under a MIPS grant, to isolate that specific strain of algae. Now they started with thousands, hundreds of thousands of different strains, and they managed to isolate one that just happened to be right here from Back River, and it provided the highest amount of lipid content, which means biofuel, all right, and also omega-3 fatty acid, right? That's what the lipids will do. Also other pigments like lanthanum and lutein, which are good for optical cleansing and surgery and whatnot for optical. So there's a lot of high-value products inside the algae itself. So the algae is critical. And the way we grow the algae, we grow it extremely fast, using the right light, the right intensity of light, right wavelengths of light, all of that in order to have it consume very, very high amounts of greenhouse gases very quickly. So you'll see in one of our tanks the lights that are inside the tank. The tank itself is made out of a very thin mylar, so the cost of a closed bioreactor we've forced down from hundreds of thousands of dollars to under $1,000 a tank. So the cost of a closed bioreactor, we've revolutionized that. The injection of the flue gas, we've revolutionized that by the proper injection of the flue gas into the algae culture. Very, very small bubbles. So there's a lot of components to our technology that brings us to the product. The product also, after the fact, after we mitigate the greenhouse gases, we have two things that are high-value products. Oxygen that's vented from the photosynthesis process, which we can sell into the marketplace, and the algae itself. And the algae is pharmaceutical, nutraceutical, biofuel grade. I mean, it's a high-value product. So anyone who applies our technology or our product to their technology of generating power, bringing fossil fuels to become a clean energy source of energy, we now can buy down the cost of the installation of our technology through the sale of the byproducts that we produce. We've been at this for years, and it wasn't until MIPS, and we've tried 6 different DOE grants, agricultural grants, we've tried a lot of different things, but it wasn't until we presented our technology to the Maryland Industrial Partnerships and they granted us first phase 1. That's when we really took off. I mean, you can't say enough about the work that MIPS does, and we've really been grateful for them, and we happen to also been fortunate enough to get a phase 2. And in phase 2, they've extended what we're doing, and the university is now helping us do what we're doing here at this site.
So we were very excited when HY-TEK Bio and Bob Morose came to talk to us about their project. This is the ideal project for the Maryland Industrial Partnerships. MIPS is a program that acts to connect University of Maryland faculty to companies that need our resources and our help.
So these algae represent many different strains. Some of them can tolerate very high CO2 level, and that's where we started with our collaboration when Bob and Jack are interested to use some of these strains and also to isolate some of these strains that can tolerate high CO2. And you can see that when the CO2 increased, some of the algae cannot even grow. So only a few strains that can survive. And then we pick those strains and use those strains as a candidate strain for HY-TEK Bio's interest.
One of the other things that MIPS did for us is it introduced us to the Maryland Intellectual Property Legal Resource Center. That's on the grounds of the College Park at the University of Maryland. They provided us all of the legal work required on our patents in order to get the patent application in place. What's really neat about that is just the technology knowledge base that the university has available to it, and then applied to their Intellectual Property Legal Resource Center, all sitting there in one room. And all of that because of the Maryland Industrial Partnerships introduced us to that environment. So we're really, really tickled for that as well.
103 million gallons on average sewage flows through right under our feet every day. That's the sewage that comes from Baltimore City and Baltimore County. And that's where we'll be growing our algae. We'll be growing with flue gas and wastewater from the Back River Wastewater Treatment Plant.
And we're looking really forward to not only doing all of this project, we also have 10 other companies interested in what we're doing, and it looks like we're going to leap right into a commercialization probably within the next year or 2 years.
This is an ideal company where they're trying to bring a new product to market and they need the help and expertise of the University of Maryland. So the Maryland Industrial Partnerships provides this key funding and this key resource to the company that not only can do good science but also can bring these products to market and create an impact for the business as well as for the state of Maryland. So it's our hope that this company will create jobs in Maryland and at the same time remediate the Chesapeake Bay.